Hi, my name is Kemde Oko. I'm a team member of the HESTEC Greenpower Car Competition USA. I'm an industrial engineering graduate student. My main responsibilities were to research on the lightweight materials used for the car, as well as to assemble the parts of the car, and also to reach out to our sponsors. We decided to go with fiberglass because of its durability, its cost effectiveness, its malleability, and its strength.
Hello, my name is Aide Jadinino. I'm a mechanical engineering student of Texas A&M University, and I'll be graduating by December 2018. I worked on assembling the body and the bottom floor panel of the electric vehicle. Thank you.
My name is Matthew Bast. I am class of 2020 and I'm in charge of the bodywork.
Hello, my name is Noy Martinez and I'm a mechanical engineering student at Kingsville. I graduated 2019 and I helped assemble the car.
I was able to help in creating the fiberglass body of the car because this semester I was taking a manufacturing of composites course. Creating the body, we had to create the nose. We decided to use spray foam as the mold. This didn't work out so well because while the fiberglass was still setting and curing with the resin, the foam was also bubbling and deforming. So once the actual cast of the fiberglass was finished, it had bubbles and voids and imperfections in it.
I'm Charles Standy, class of 2020, and I'm a mechanical engineer at Texas A&M Kingsville. And here we got our Greenpower car, an electric car. We've been working on it for a couple weeks now, and we're still waiting on a couple components, but we're going on it as good as we can.
We used a lot of different metal cutting and welding processes, such as MIG and stick welding. We used plasma cutters. We reduced the weight and the overall aerodynamic impact, letting us go further with our batteries. Wiring restrictions. We had to lengthen a couple of wires for the taillight, and within a couple of hours we had the car fully wired, and we were testing out the horn, the brake lights, and the on-off switch for the motor.
I'm Josh Ordonez. I'm a mechanical engineering student here at Kingsville. We have the opportunity to compete in Greenpower racing. This is the car we've got to build. In addition to being a driver for the team, I've helped assemble it. The bodywork is soon to come. One of the main design points we decided to do with the bodywork was to make the tail extrude backwards behind the rear axle and to come to a point where it lifted up from the bottom and met down in the top. We decided to do this after looking at previous designs and researching how aerodynamics affects vehicles. Another thing that I realized as a driver was how to actually drive using apexes, what an early apex is and what a late apex is.
My name is Tanush Chaudhary and I'm a part of Kingsville Racing. We made this electric car here in charge of the electrical components of the car. The batteries haven't arrived yet.
So my specialization was electrical engineering. So what I did was assemble the electrical components along with the help of some of the other members. We had people from different cultures and backgrounds, mainly mechanical and electrical, working on this project. Throughout the duration of this project, we honed our problem solving and troubleshooting skills, and also gained a lot of technical experience through our combined individual knowledge. We had to follow the instructions down to the point, as we did not want to violate any of the rules and regulations set down by Greenpower.
Hi, my name is Taiwo Oladile. I'm in mechanical engineering. I'm a part of the team for the Greenpower Car Competition USA. I'm representing Texas A&M Kingsville. We decided to go with fiberglass because of its properties and costs. The major expenses for the project came from the car kits, fiberglass material, and the paints used on the car. For the car kits, Greenpower covered all the costs for the car kits. Then we got another sponsor, Diamond Fiberglass, located in Victoria, Texas. They provided the fiberglass and other materials needed for installing the fiberglass on the car.
With the fiberglass, we had some problems. First, determining how we were going to buy the material. Once we did all the research on how much square foot we were going to need, and what kind of material we wanted, we decided to look for sponsors. And Diamond Fiberglass actually sponsored us the entire amount of materials that we needed. So a huge shout out to Diamond Fiberglass. Thank you a lot. We wouldn't have been able to do it without you guys. And another problem that we faced was our time constraint. We didn't get our vehicle until January 22nd, and we didn't get the actual motor and the battery until March 3rd. So you can see with that kind of timing, it's very hard to get a nice, finished, perfect design. But at Kingsville, we pride ourselves in good work, so we were able to get a very, very decently made design done. So right now we're working on mounting the motor into our vehicle. We're installing the batteries as well and just making sure everything's running properly. Our main idea right now is we're going to have a back flap that's detachable, so during the race, should we need to work on the batteries or fix the chain drive at all, that's easily accessible and we can work on it during the race.
We gained knowledge and experience with tools and techniques that went into building this car that improved us as students as well as engineers. Here in Kingsville, we continue to work hard, network with the community, and strive to advance Javelina engineering. We are A&M Kingsville, the pride of South Texas. Thank you for watching our video. We appreciate your time.